Hello and welcome to Algebra 2 Lesson 6. In this video, we're going to learn about solving for a specified variable. So in many situations, we are given equations with no numbers involved. Now, in this lesson, we're going to talk about some basic formulas where we have equations where the variables describe a relationship. Let's start out by looking at the distance formula. And you'll probably recall this formula from your Algebra 1 course because we use it on our motion word problems. So we have that distance, which is generally represented with d, is equal to the rate of speed, which we represent with r, times the amount of time traveled, which we represent with t. Now, we've all been on a road trip before, and let's say you're on a road trip and you're traveling at 80 miles per hour, and you do this for 3 hours. Well, you can plug that into the distance formula, and you're going to realize that you went 240 miles. So again, all I would do is I would plug in, I'm going 80 miles per hour. That's my rate of speed. My time for this trip is 3 hours. So 3 hours. Now forget about the units for a second. Just multiply the numbers. If I multiply 80 times 3, I get 240. And now you can think about the units. If I'm traveling in miles per hour, then I went 240 miles. That's going to be my distance. So we can see that this distance formula is very, very straightforward. But one thing that we can do is we can manipulate this formula and we can solve for the rate of speed, or we could solve for the time traveled. So let's say I came up with a different scenario and I had different inputs. Let's say that in this scenario that I gave you a distance that was 550 miles. So that's how far you traveled. And let's say the amount of time it took to go 550 miles was 11 hours. So your time is 11 hours. Now, in order to get a solution here for r, because the rate of speed right now is unknown, what I would want to do is solve this formula for r. So what I'm going to think about here is just treating t as if it's the coefficient of r, right? If I saw something like, let's say 12 is equal to 4r, if I want to isolate r, we know we divide both sides of the equation by 4, and we get 3 is equal to r. Well, it's no different here. If I want to isolate r, all I'm going to do is divide both sides of the equation by t. It doesn't matter that it's a variable in this case. So this will cancel with this, and I'm going to have that r, or the rate of speed, is equal to the distance over the amount of time traveled. So now that I have it solved for r, what I can do, let me just kind of rewrite this. What I can do is I can plug in my inputs. I can plug in 550 miles here, and I can plug in 11 hours here. And if I think about the numbers there, 550 divided by 11 is going to give us 50. So I know my r there is 50. And when we think about the rate in terms of the units, we're talking about miles per hour, right? So miles per hour. We have miles here, we have hours here. So that's going to be miles per hour. So my rate is 50 miles per hour. Now let's say I gave you another scenario. Let's erase this real quick. And let's say that I now gave you a distance. Let's say it's 300 miles. And let's say I gave you a rate. Let's say the rate is 60 miles per hour. And I asked you for a time. So now this guy is the unknown. So I can solve the formula for time. So if I want to solve for time, I just divide both sides of the equation by r. And I'm going to get that time is going to be equal to distance over rate. So once I have that, I plug in. So I'm going to plug in for distance, that's 300 miles. I'm going to plug in for the rate of speed, that's 60 miles per hour. And so 300 divided by 60 is going to give me 5. So t, or time, is 5. And again, we have miles and we have miles per hour, so we're talking about 5 hours here. So the time is going to be 5 hours. So that's just one example of how you have an algebraic formula, and you can manipulate it for what you need based on the problem that you're given. All right, so let's think about another common formula. This is the perimeter of a rectangle. So this is more used in geometry. I know by the time you get to Algebra 2, you've taken a geometry course. Maybe you haven't, but the perimeter of a rectangle is given as P, which stands for perimeter, which is equal to 2 times the length plus 2 times the width. So as an example, let's say, and this is your width here and here. This is your length here and here. Let's say you have a length that is equal to, let's say, 8 feet. And let's say you have a width that is equal to, let's say, 4 feet. If I told you to calculate the perimeter, you just need some basic arithmetic, right? You're going to plug in. So the perimeter is going to be equal to 2 times, my length is 8 feet. So I'm just going to put an 8 in. I'll deal with the units in a minute. Plus 2 times my width, I have 4 feet. So I'm going to put 4 in. So my perimeter P is equal to 2 times 8, which is 16, plus 2 times 4, which is 8. 16 plus 8, we all know, is 24. So the perimeter in this case, if we think about the units as well, would be 24 feet. Okay, 24 feet. Now, that's easy to calculate, but what if I gave you a different scenario? Let me erase this real quick. And let's say that I gave you a scenario where I told you what the perimeter was. Let's say the perimeter is now 40 feet. And let's say I gave you one of these. Let's say I gave you the width, and I said that the width is going to be 7 feet. Well, how would I find out what the length is? So my L here is unknown. Well, I can solve the formula for length. And how do I do that? Well, I want to get this term by itself to start. So that means I would subtract 2w away from each side of the equation. This would cancel. And on the left, I would have P minus 2w is equal to 2L. Now, to get L by itself, I have a coefficient. I have that 2 there. And so I'm going to do the same thing I've been doing. I'm just going to divide both sides of the equation by 2 so that L can be by itself. So this will cancel with this. And I'll have L is equal to, I'll have P, or perimeter, minus 2 times W, or width, over 2. Now, all I need to do once I've solved for length is just plug in. So I know the perimeter is 40 feet. So let me scroll down and get a little room going. So for P, I'm going to plug in a 40, and I'll deal with the units in a minute. Minus 2 times, for the width, I'm going to plug in a 7. And this is over 2, and this should give me my length. So 2 times 7 is 14, so let's just erase this and put 14. 40 minus 14 is 26, so I'd have 26 over 2, which is 13. So my length here is 13. And again, you want to use the units, so it will be actually 13 feet, right? 13 feet. Now, you can check that with the original formula. Let me kind of erase everything here. And if I go to the original formula, if I plugged in a 13 here, and I plugged in a 7 here, would I get a perimeter of 40? And again, we're dealing with feet in terms of the units. So 2 times 13 is 26, plus 2 times 7, which is 14. Yeah, that would work out. 26 feet plus 14 feet would in fact give me 40 feet. So that works out. Now, as another example, what if I am given the perimeter and I'm given the length? Well, now I need to solve for the width. So let's say this is unknown. And let's say I give you a length that is 5.5 feet. And I give you a perimeter that is 16 feet. Well, now I want to solve the equation for W, or the width. And it's the same thing, it's just a little bit different. I'm going to subtract away 2L from each side of the equation. So that's going to cancel. I'll have P, or the perimeter, minus 2 times L, or the length, is equal to 2 times W, or the width. And again, divide both sides of the equation by 2 so you can isolate W. And what I'm going to have is that W, or the width, is equal to perimeter minus 2 times the length over 2. So if I just plug in my inputs here, if I plug in a 16 here and I plug in a 5.5 here, what's that going to give me? Well, I would have 16 minus 2 times 5.5 is 11. So this would be 11. So you'd have 16 minus 11, which is 5. So you'd have 5 halves, or 2.5 as a decimal. And don't forget the units, so this would be 2.5 feet. So my width is 2.5 feet. So let me erase this, and we'll put 2.5 feet. So again, another great example of how we have an algebraic formula, we have more than one variable that's involved, and we can solve for whatever variable that we want. It's just based on the information that's given in the problem and what we need to find. All right, so here's another great example. We have Fahrenheit to Celsius. So if you live in America like I do, all of the temperature readings that you get are generally going to be in Fahrenheit. I know if you take a science class, you get a lot of stuff in Celsius and things like that, but in general, when we report a temperature here in America, we get Fahrenheit. Now, if you're in another part of the world, you might get it in Celsius. So you need to be able to convert back and forth. So this is the formula. If I give you a temperature in Celsius, you plug it in, you multiply it by 9/5, you add 32, you get a temperature in Fahrenheit. So we can try this out. Let's say I wanted to convert 25 degrees Celsius to Fahrenheit. And I'm not going to write that. I'm just going to put to F. So what would I do? I'd plug in a 25 here. Plug in a 25 here. So my Fahrenheit is going to be equal to, we'd have 9/5 times 25 plus 32. We know that this would cancel with this and give me 5. 5 times 9 is 45. So you're looking at 45 plus 32. And we can do that in our head. 5 plus 2 is 7. 4 plus 3 is 7. So 25 degrees Celsius would be 77 degrees Fahrenheit. So those two are equal to each other. Now, let's say that I gave you a temperature in Fahrenheit and I wanted to go to Celsius. Well, I would need to solve the formula for C. So how would I do that? Well, I want to isolate C. Right now, F is isolated. So let's start out by just isolating this, and we'll subtract 32 away from each side to do that. So I'll have F minus 32 is equal to 9/5 C. And what I want to do here is I have a fraction as the coefficient for C. So when I have a fraction, I can just multiply by the reciprocal. So I can multiply by 5/9. And of course, what I do to one side, I've got to do to the other. But this is going to cancel itself out, right? This is going to be 1. So on the right side, I have C. On the left side, I'd have 5/9 times F minus 5/9 times 32. Now, of course, I can write this more cleanly by saying that I have C is equal to, I just switch which side it's on. I like my variable to be on the left. Over here, I would have 5F minus 5 times 32 is 160, so 160. And this is over the common denominator of 9. Now, I just showed you that 25 degrees Celsius was 77 degrees Fahrenheit. Let's try it out in this formula. So let's plug in a 77 here and see if we get 25. So 5 times 77 is 385. So what I'd have is C, or Celsius, is equal to 385 minus 160 over 9. If I subtract 385 minus 160, I get 225. So I'd get 225 over 9. And we know this is going to be equal to 25. So again, when I go from 77 degrees Fahrenheit back to Celsius, I get 25 degrees Celsius. So let me rewrite this formula. C, or Celsius, is equal to 5F minus 160 over 9. And let's try just one more. We'll go back and forth. Let's say that I had 37 degrees Celsius. And I want to convert this to Fahrenheit. So how many degrees in Fahrenheit? This is actually a very popular temperature that deals with the human body. So if I'm going from Celsius to Fahrenheit, I want to plug into this formula here because it's solved for Fahrenheit. So what I can do is I can plug in my 37 here, and I would have 37 times 9/5. Well, 37 times 9 is 333. So what this would give me is F is equal to 333 over 5 plus, you have 32 there. Now to get a common denominator, I know if I multiply 32 times 5, I get 160. So this would be 160 over 5. And so 333 plus 160 is 493. So this would end up being 493 over 5. But in decimal form, you'd end up with 98.6. 98.6. So 37 degrees Celsius is 98.6 degrees Fahrenheit. Now this temperature is significant because for most people, a body temperature of 98.6 degrees is normal, right? If I take a thermometer, put it in my mouth, under my tongue, I'm looking for something around 98.6 degrees. So let's just do one more here. And all I'm going to do is just convert 98.6 degrees back to show you that this formula does indeed work. So let me erase this. And I'm going to plug in 98.6 here. And 98.6 times 5 is 493. So 493 minus 160 would be 333. So this would be 333 over 9, which we know is 37. So again, convert this back and forth. You see that, again, 37 degrees Celsius is 98.6 degrees Fahrenheit. So you can see how solving this for Fahrenheit with F and then solving it for Celsius allows you to attack any problem they throw at you. If they give you a temperature in Celsius and ask for Fahrenheit, you use this one. If they give you a temperature in Fahrenheit and ask for Celsius, you use this one. So it's an ability to go back and forth. And again, it's just based on the information given to you in the problem as far as what you want to solve for. All right, for the last problem, let's look at one that's not a generic formula. Let's just look at something you might see on your SATs. So you might get something that's like this. 2b plus az equals z minus 3g. You might say, what is this? They might say, I want you to solve this for z. I want you to solve this for b. I want you to solve this for g, so on and so forth. Let's just do one, and let's just say we're going to solve it for z. So let's solve for z. So how do we do that? Well, I've got to isolate z on one side of the equation. That means I'm going to isolate all the terms with z in it on one side, get everything else on the other. So I can subtract 2b away from each side of the equation, and I can subtract z away from each side of the equation. So this is going to cancel, this is going to cancel, and I will have az minus z is equal to negative 2b minus 3g. Now, how do I get z by itself? This is tricky if you don't have any experience in Algebra 1. If you've just gotten into Algebra, you might go, what in the world are we going to do? Well, for most of you that took Algebra 1, you know how to factor. If you didn't take Algebra 1, let me just kind of explain briefly what we're doing here. I am able to pull something that's common outside of a set of parentheses. So if z is common to each term here, I can place it outside of a set of parentheses. When I do that, what's going to be left in the parentheses is what was multiplying z. So here a is multiplying z, so it's there. Then minus. Here you might say, well, nothing's multiplying z. Well, yeah, you always have a phantom 1 there. 1 times z is just z. So really, if I factor out a z, I end up with a quantity a minus 1. And you can check that through multiplication. Z times a is az. Then minus, z times 1 is z. So you're back to what you got. So I just wrote this in a different form. And another way you can kind of think about this, let me kind of erase this real quick. If I had like terms, let's say I had 6z minus 3z, okay, for example. Here, 6z minus 3z would be 3z because I subtracted this minus this, 6 minus 3. In this particular case, I don't know what a is. But if a was 5, for example, I'd have 5z minus 1z, that would be 4z. So if a was 5, 5 minus 1 would be 4, I'd have a coefficient out there. But I don't have the luxury of that because in this particular case, I'm just given a, and I don't know what that is. So this is the best we can do. We factor out the z, and we leave it in this form, and we say it's equal to negative 2b minus 3g. You might say, well, how do I get z by itself? Well, just like if I had 4z is equal to something, I'd divide both sides by 4. Well, I'm going to do the same thing here. I'm just going to divide both sides by this quantity, a minus 1. That is what's multiplying z, so that's what I'm going to do. So I'm going to divide over here by a minus 1. And this is going to cancel with this. The quantity a minus 1 over the quantity a minus 1 is 1. So I'm going to have z is equal to, I'll have negative 2b minus 3g over a minus 1. Okay, and that's your answer for z. So if you get something like that on a test that says solve for z, that's exactly what you would do. Now, you might get different scenarios. You might have a problem that says solve for z, solve for a, solve for b, solve for g. You might have to solve for each one. In the end, you're just going to isolate whatever they want you to solve for on one side of the equation, and everything else is on the other.